This last chapter is a super short chapter. We look at one more type of graphing, which is square root functions. So far this year, we've done graphing lines, we've graphed exponentials, we graphed quadratics, and now we're going to graph some radical functions. And in 10.1, it's a square root function. Now, as the name would imply, a square root function is a function that contains a square root symbol with the independent variable, which we know is the x value. Something we talked about in a lot of our other graphing chapters were parent functions, and a parent function is just like the basic function that everything starts off at, and then you do shifting. Like in lines, it was y equals x. In parabolas, it was y equals x squared. That's the basic one, centered at the origin, very friendly and simple. So the parent function for a square root function would be y equals radical x. Now, the domain for this specific function over here, for example, f of x equals radical x, the domain is x is greater than or equal to 0, because you can see that there's no x values on the graph that are in the negatives, and the range is also in the positives, so the range over here would be y equals greater than or equal to 0. Obviously, if there's some sort of shifting, then it would change. Now, as you know from taking square roots of numbers, the value of the radicand, or the number under the radical sign, can't be negative, because you can't take the square root of a negative number. So back when we first talked about domain and range and we would say what they are, I told you that the domain was typically all real numbers, but I also warned you that that's not always the case. This is the moment where it's not the case. The domain is not going to be all real numbers, because the domain can't have negatives under the radical sign. So the domain of a squared function is all the x values for which the radicand, meaning number under the radical sign, it has to be greater than or equal to 0. So we're going to look at the restrictions that would exist with square root functions, and when we look at our domain and range, the domain in this case is not going to be all real numbers. So then you say to yourself, well, how do I know what the domain is? Well, you ignore all the stuff in the function, and if we look at example 1, we're going to ignore all the numbers that are not underneath the radical. So in this case, it's just the 3 that we're going to ignore, and we're just going to look at x minus 5. So the rule is, according to this statement up above, the rule is that the number under the radical sign has to be greater than or equal to 0. So what we want to do is we want to see, when does x minus 5 become greater than or equal to 0. So obviously you can easily solve that. That means that the graph won't have any values less than 5. Any x value less than 5 will not be on the graph. There won't be a dot anywhere. So to answer this question, describe the domain, we would say the domain is x is greater than or equal to 5. All right, let's graph one. In example 2, it asks us to graph f of x equals radical x plus 3. This one's a little different because the 3 is not under the radical sign, only the x is. So we just have to pay attention to what our values of x could be. So if all we're concerned about is the x, then obviously we're going to have x values that are greater than or equal to 0. So the only rule is that you can't use negative x values. So here's the thing. Remember I told you back when we were graphing, you get to pick the numbers to plug in, right? And if you get to pick the numbers, pick numbers that are friendly. So what types of numbers are going to be friendly to put under a square root sign? Obviously numbers that are friendly square root answers. So I can plug in 0 because you can take the square root of 0. I can plug in 1 because I can take the square root of 1 very easily without a calculator, without getting a decimal. But I'm not going to do 2 next, because the square root of 2 is a crazy decimal. And if I get to pick the numbers, I'm not going to pick numbers that give me crazy decimals. So what's the next number that won't give me a crazy decimal? Well, it's going to be 4, because that's my next perfect square. So really what you're looking for is you're trying to put perfect squares under that radical sign. So the next perfect square is 9. Okay, and you could keep going, right? Like you could do 16, 25. It's just you need that space on the grid, obviously. But I'm not going to pick like just random numbers. I'm going to pick numbers that have friendly integer answers. So now I just go through and I calculate. So let's do the square root of 0 plus 3 is just the square root of 0. So that's 0 plus 3, which is 3. The square root of 1 plus 3 is going to be 4. The square root of 4 plus 3 is going to be 2 plus 3, so that's 5. And then the square root of 9 plus 3 is 3 plus 3, which is 6. So you see a pattern in the y values, you kind of see a pattern in the x values, and now let's graph it. So you know what? You can pause the video. You don't need to watch me plot points. So plot your points, make the curve, and then compare yours to mine. Pause the video. So there's my curve. They want me also to describe the range. Well, I described the domain right over here. This is the domain. But the range is my y values. So the possible values for y are that y is greater than or equal to 3 because that's the first point where my graph starts. So here's a chart that talks about all the different shifting that you would want to do with square root function. It's really stuff that we already know in terms of how to shift it left or right, up, down, make it flip. So you can read that. Really, what you want to focus on is not so much what's in this chart. Really, you just want to make sure that you are doing your order of operations and you're thinking about what numbers make sense under the radical sign. So let's look at example 3. Now, when we are trying to first make our chart, we want to look for what number makes sense under the radical sign. So you go under the radical sign, you just look at x minus 2, and you want to say, when does x minus 2 become greater than or equal to 0? Because remember, you can't have negatives under the radical sign. So the smallest x value that you can pick is 2. Okay, so then you go to your chart, and you start with 2. But you don't just go like 3, 4, 5, 6. What you have to do is think about what numbers make sense underneath the radical sign. So, for example, I'm not just going to pick any random number because I don't want to get a decimal. So what you want to think or make a list of your perfect squares. So remember, the perfect squares are 1, 4, 9, 16, right? Those. Okay. So if you plug in 2 underneath the radical sign, you would get the square root of 2 minus 2, which is 0. Okay. Now, what number does x have to be to make it 1 underneath the radical sign? Meaning, what number minus 2 is 1? Well, it's 3. 3 minus 2 is 1. So check. I did 1. Now you go to your next perfect square. What number minus 2 is 4? You're trying to get a 4. What number minus 2 is 4? Well, that's going to be 6. What number minus 2 is 9? That's going to be 11. What number minus 2 is 16? And you can keep going, obviously, if you wanted to get more dots. But you go through the perfect squares. So it doesn't really look like there's a pattern in the x's, but the goal is to plug in a number that's going to give you a perfect square. So now you just crank it through the formula. So this is going to be negative radical 2 minus 2, which is negative radical 0, so that's just 0. Then I have negative radical 3 minus 2, which is negative radical 1, so that's negative 1. Negative radical 6 minus 2 is negative radical 4. Negative radical 11 minus 2 is negative radical 9. I'm not going to plug in 18 because I know it's not going to fit. All right, so now that we have our table, go over, plot those points. Pause the video now. So there's my graph. I had to kind of fake it on that last point. and it wants me to compare it to the graph of f of x equals radical x. So that was the very first graph that we looked at the beginning of the video. I'm just going to pop it up on your screen. So you can see that it got shifted 2 to the right and flipped, which you should be able to notice by looking at the original equation. All right, let's look at one more together. So in this one, we've got a whole bunch going on. We've got a flip, we've got a stretch of some sort, we've got a horizontal shift and a vertical shift. So let's describe it all. So the first thing I notice is that the coefficient in the very front is negative, so that means it got flipped downward. Since there is a coefficient, if you think back to that chart a little earlier that I told you can skip over, the number outside does the same thing as it did before. It makes it like stretch. So this is a vertical stretch. If it was inside with the x value, because it would impact the x value, it would be a horizontal stretch because the horizontal axis is the x-axis. But since it's outside, it's going to impact the y value, so it was vertically stretched. We also know that because of the -3, it was shifted to the right 3. Be careful, it got shifted right 3. The minus inside means right, because what do you need to make 0, right? If you think about when we were solving and factoring, you need 3, positive 3, so it got shifted to the right to positive 3. And then the outside number here, that means the vertical got shifted, so it got shifted 2 down. All right, don't freak out. It wants us to graph it, but remember, we're just going to look for what values we need to make x perfect squares, or what number we need to make perfect squares under the radical sign. So I'll write our perfect squares down again, 1, 4, 9, 16. We probably won't be able to fit 25, right? Or 36 or whatever. Okay, so the first thing I'm going to do is I'm going to find my smallest x value. So that's where x minus 3 is 0. So the x value, or the domain, has to be greater than or equal to 3. So I'm going to start my table at 3. Now I need to say what number does x have to be a perfect square. So if I want to get 1, what number does x have to be to make 1? What minus 3 is 1? Good, 4. Okay. What number minus 3 is 4? Now go to my next perfect square. What number minus 3 is 4? That's going to be 7. What number minus 3 is 9? That's going to be 12. And I probably can't even fit 12, so I'll just scribble that out. Okay, so why don't you pause the video, plug those numbers into the equation, see what you get, and graph it if you think your table's right. If you don't think your table is right, then play it before you graph it. All right, I got -2, -4, -6. Feels kind of weird, but let's see if we get our square root curve. All right, so kind of felt like it was going to start making a line, but then I saw that curve. Make sure you draw the full curve. And that's how you graph a square root function. If you have any questions, write them down and ask me when you talk to me next.